Okay, in part 2, we're going to talk about the characteristics of the exponential functions. This is actually a chart that you can find in your ebook. If you will go to section 3.1 under course contents in my math lab, you should be able to see this diagram. You could print it also if you would like to. But what's graphed here is 4 exponential functions. This one that is the most steep here, rising to the right, is y equals 7 to the x power. And then this graph is y equals 2 to the x power, which is what we did on the previous worksheet. And then over here we see y equals 1/2 to the x power, which we've also graphed. And then y equals 3/4 to the x power is here. Okay. If you notice, with these two functions, our base, which we usually call b, is greater than 1. Okay, when the base is greater than 1, you will see that your y values will increase as your x values increase. So we'll see that curve that's rising to the right. Over here on this side, these two, we both have fractional or b values that are less than 1, okay, but still greater than 0. When this happens, you will see that the graph, as your x values get larger, your y values decrease. So we'll see this shape of the graph here where it looks like it's rising to the left. Okay, below also you'll find this list in section 3.1, the characteristics of exponential functions that are of the form f of x equals b to the x. Just some properties and things here that you should know. The domain of f of x equals b to the x consists of all real numbers. Okay, you can look at your graph and tell that. The range, however, is just going to be from 0 to infinity. And notice it does not include 0, so we have the parenthesis around 0. The graphs of all the exponential functions of this form will pass through the point 0, 1. And that's just because, like we said earlier, if you raise something to the 0 power, it will equal 1. So your y-intercept is always going to be 1. There is no x-intercept. And as I talked about up here, as far as the shape of the graph, if b is greater than 1, then your function is going to have a graph that goes up to the right and is an increasing function. The greater the value of b, the steeper the increase. So we can see that. I had a b value of 7 compared to a b value of 2. 7 is much more steep than 2. Okay, then number 4 says if b is greater than 0 and less than 1, then your graph is going to be of this shape. Okay, where that it goes down to the right and it's a decreasing function. Again, the smaller the value of b, the steeper the decrease. This function is also a one-to-one function, which means it does have an inverse. Okay, remember your horizontal line test. If I draw a horizontal line, it's going to intersect the graph at one point, so that means that it does have an inverse. Okay, and then number 6. We say that the function approaches but does not touch the x-axis. The x-axis, or y equals 0, is the horizontal asymptote for these exponential functions. Okay, again, you need to look at this as being kind of the parent graph, the parent shape. These functions can be can have transformations, which means they can have vertical shifts, horizontal shifts, and reflections and things also. But these are the main characteristics of the function if it's of the form f of x equals b to the x.